Hey y'all, and welcome to the first video lesson of the year, second lesson of the year. Today we're going to talk a little bit more about types of data, and we are going to identify the types and the different measurement levels in this lesson. This lesson is pretty vocabulary heavy, much like the previous lesson, so do please make sure that you are pausing to write things down. Listen first, then pause to write them down. As ever, if you have any questions as you're going throughout the lesson, please do ask me for help if you need clarification. Write down what will be useful to you. If you don't feel like you need to copy everything word for word, that's okay. Just write down what's useful to you. So there are two different types of data that we will talk about. We spoke about this in the first lesson a little bit, very briefly. And I referred to qualitative data as categorical data, which I know I have written right here as well. So two different types of data, qualitative or categorical, and quantitative. Qualitative variables are those types of variables that we're not measuring. They are characteristics or attributes, things that we can put into groups without measurement. And my example in class the other day was freshman, sophomore, junior, senior. Those are, so your class level is a qualitative or categorical variable. Quantitative variables have units. They're things that we can measure: height, age, weight, grade, point average, things like that. When we get into the quantitative types of variables, there are two types of quantitative variables: discrete and continuous. The thing to know about discrete variables are those are variables that can be counted. We are able to count them. A continuous variable has an infinite number of possible values, which means we cannot count them. And we usually have to find them by measuring. And those ones are the ones that are a bit messy because they are fractions and decimals. When we count things, they're not going to be fractions and decimals. Continuous variables tend to be those and maybe be a little bit messier for that reason. Again, I'll remind you one more time that if I'm going too fast, that you can listen to me first, pause the video, and then you can copy down what you need to copy down. So I want you to pause here, and I want you to think about each of these, and I want you to decide if each of these would represent a discrete variable. Remember discrete, and I'll put a note here. Discrete means that it can be counted. So think about whether or not this scenario represents something that was counted, or a continuous variable, which is something that can or is found by being measured. So those are the keywords you're thinking about when you're deciding discrete or continuous. So pause here, have a think about those, maybe jot down your answers, then press play, and I will have the answers up here and I will discuss them. So check your answers here. I use the word C or the letter C for continuous and the letter D for discrete. If you want to clarify it all, please do ask me. The two that are discrete are examples of things we can count. We can count the number of touchdowns a quarterback scored in a year. They're not fractional. They're not decimals. We can actually count them up. The amount of money a person earns per week at a fast food restaurant is something we can count. There could be decimals here. However, money is in specific units. The smallest you can break that down is into cents, and that is something we can count. We can count by the penny, even if it would be kind of painful. The other two are continuous because you will have to measure them. So when we're measuring the number of hours, that can be fractional. We can get into seconds, milliseconds, things like that. And weights, of course, is another thing that we are measuring, and we can get into smaller and smaller fractions of weights. So we've talked about the two different types of variables, and then we got a little more specific about quantitative variables. And now we can talk about levels of measurement. And so nominal here is sort of like the basic level of measurement. We are going to be classifying into categories. So this will be for categorical data. And the thing about a nominal level is when we classify something into categories, there is no ranking involved in those categories. So again, a nominal level of measurement would be your class level, freshman, sophomore, junior, or senior. Actually, I'm going to take that back. We probably can put those in a ranking in terms of age. So I'll back off on that one. See, we all make mistakes. We can put people into groups like, okay, teachers, math teacher, English teacher, language teacher, science teacher, history teacher. You might have your own opinion on that, but we're not ranking what department you are in. So I'm going to say type of teacher. Of course, math is my favorite. In the ordinal level, we can put things into categories. However, we can now rank those categories, and those rankings are pretty explicit. So I believe maybe when the band, or if we have any sort of like speaking thing, we can rate people as a, pardon me, superior, average, or poor. I'm not exactly sure how band gets rated, but I know our band does really well. We can put people into the categories. You get a superior rating, maybe as a band, or if you are some sort of doing some sort of speaking engagement, maybe you get an average rating. You do okay, or you get rated as poor. We classify those as three different categories. However, there is a ranking between them. Superior is the best, poor is the lowest. But we don't get any more specific than that. There's not like a poor plus or an average minus. And these next two have to do with types of measurement. So an example of an interval level is temperature. Another one would be IQ. So there are precise units of measure. Temperature, we can do Fahrenheit or Celsius. 71 degrees is different than 72 degrees. In an IQ rating, we go from 1 to 1 and up. And an IQ of 1 is different than an IQ of 2. An IQ of 10 is different than an IQ of 30. The thing here that is important is this no meaningful zero. Okay, we can say it's 0 degrees, but that does not mean there's not any temperature. Or that there's not any heat at all. 0 is not an absence of warmth. It's cold. We don't measure IQ at a 0 and say somebody has 0 intelligence. In the ratio level, there is a true measure of 0. So some examples, some simple examples of a ratio level of measurement would be height and weight. And then this thing where it says like true ratios exist when we have two different members of the, we measure two different members of the population. So somebody like me, I'll simplify and say I'm 5 feet tall. I'm a little taller than that. And then we could have somebody that is 7 feet tall. And we can write that as a ratio to show the relationship between our two heights. So that ratio is a key word. So one more time, pause right here. And I want you to read through these 4 scenarios and decide which level of measurement is being discussed: nominal, ordinal, interval, ratio. Use the definitions you wrote down. Raise your hand, ask for help. You can talk to a partner, but try these 4, press pause, and then when you press play, I'll have the answers up. So here are the answers on the left here. The first one's ratio. Second one is nominal. Then interval and ordinal. So the first one's ratio. We do have a true 0 of your age can be 0, pre-birth, not born. Colors we can put into groups, but there is no ranking. You might have a favorite color, but there really is no specific ranking. Temperature is at an interval level like we discussed before. There is no true 0 for temperature. And the ordinal level for the last one is actually the example I used. I must have been thinking of this example when we have the ratings of these bands playing. There is a way to order them or rank them from best to worst. So that is all for this lesson. If you do have questions, please always ask, and I'm glad to help and have a conversation. If not, that's it.